Hello there, and thanks for choosing this content. Just a quick disclaimer to say that all views in this video are personal and belong entirely and only to the person saying them. They do not reflect the views, stance, or policy of any other person, organization, employer, or entity. And with that being said, let's go to the video. Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. Is virtualization dead? That is the question we are asking today. Leo already knows we've had these conversations before, so we may already know the answer to this, but we're going to go through the motions anyway and have a conversation about it. So namely, we are talking about virtual machines and hypervisors. That's what we mean by virtualization. So are these things of the past? You may, yet again, kind of already know the, as I said, the answer yourselves, but we'll maybe kind of get you guys to be the judges of that. So we'll just kind of really present the evidence and we'll see where things go on this particular talk. Again, this is part of this kind of ongoing, loosely coupled series of the Dead Tech series, as it's become known. I have done quite a few of these talks already. We've talked about a lot of stuff in the past. I shared a conversation with Leo in regards to OpenStack. That was the previous one that we did together. But I've also covered things like, is the operating system dead? Is DevOps dead? And so on. And there's, I think, other ones around in that series. Check out the playlist. There should be a playlist of all of these available by now. If not, it's coming soon, depending on when you're watching this. But there will be a playlist of these. I've also done a panel discussion, which is coming out soon. So again, depending on when you're watching this, it might be out already. If not, if you're watching it early on, it'll probably be out fairly shortly on the channel as well. So let me say hello to Leo officially. Leo is my special guest. He's back on again to the channel. So he's no stranger to the channel. Can you believe this? He's actually back on again. Leo,
hey, Richard, thank you for having me again. And, you know, I don't know why I have this special privilege to be on the Dead Talks.
On the Dead Talk, because we're good at talking about those things and we know what we're talking about, maybe. So, Leo, let's do a quick intro to you, please. And yeah, just tell us a little bit about you and what you've been up to recently.
Hi, my name is Leo. Again, the second time on the channel. My background, ages in the IT industry. I met Richard in our joint days at IBM, and then we kept in touch. And
Here we are.
Shall I say again? We were supposed to start this channel together, and we didn't. No,
I think we covered that last time.
We don't go into that. And recently, I ran my own technology business called Kubernetes, and basically, we are an independent cloud provider.
Fantastic. Yeah, and more on that and whatever else Leo gets up to. He's got his own YouTube channels. All of that will be in the description of the video, so do check that out, please, and do subscribe to him as well. Okay, so we're going to really look at, as we said, virtualization. Is virtualization dead? And we're going to look at it from a virtual machine and a hypervisor point of view. Now, this is not going to be an exhaustive talk. I don't think we can cover everything in this particular talk. So again, we'll maybe kind of just give you some breadcrumbs for you guys to follow, and then for you to kind of go and do your own investigation and kind of, do your own judgments. But depth of virtualization, that's kind of what we're talking about. So the reason I think I kind of really wanted to mention it and bring it into this, like I said, loosely coupled series of talks is because it's no longer the latest, unit of computing. And what do we mean by unit of computing? You can look this up, but essentially anything that can actually really kind of run your application. So it can kind of do processing, can have some kind of storage, whether it's memory or or physical storage or whatever, and it can do some kind of connectivity or networking. So that's kind of normally what's loosely sort of termed as a unit of computing. So before virtualization, before virtual machines, we had physical servers. So you could have a physical server and you can run your application on that. You can do the processing, you can store some stuff in memory or disk or whatever, and do some network and some connectivity of that application. So that's a unit of computing. And then we moved from that in the early 2000s, as other people might argue, mainframe and mid-range people might argue and say, it was done in the 90s, we were doing it first. But essentially for the sort of the x86 sort of computing world, in the early 2000s, with the advent of things like virtualization with vSphere from VMware and so on, we really started to really sort of do proper virtualization, running virtual machines, running hypervisors on our physical servers. So VMs really became the new unit of computing, and that kind of essentially replaced, running physical servers. Obviously, after that followed the kind of the so-called sort of server consolidation wars and so on. So everybody was consolidating their physical servers and and replacing them and running everything on virtual machines and so on. So that was kind of really where things were, and that's kind of pretty much been the same really for the last sort of 2-3 decades when it comes to virtualization. Not a great deal has actually changed, and again we'll cover a little bit of that later. But obviously, virtualization itself has been overtaken by containers and orchestration, at least. So we've kind of had a massive fall from grace when it comes to that, from a very, very tall height, I think. And obviously, beyond that, even beyond containers and orchestration, we have things like WebAssembly or WASM. Now, I've done a talk on WASM, so if you want to check that out, there'll be a link in the description of the video, so do check that out. I've done recently a talk on that on the channel. But basically, kind of cloud native and the whole sort of cloud approach has really frozen out virtualization. Yes, you can still run virtual machines, in the cloud, and you can do your EC2s and whatever else, your VPCs and what have you, can all kind of create that type of environment. So essentially kind of really copy what you've had in the data center and do that in the cloud. But obviously that's not really kind of cloud native. That's not really a sort of an optimized way of running cloud. And hence why we're actually seeing a little bit of a backlash on that recently, or an alleged backlash on that recently. So virtualization, why is it dead? It's because it's no longer that latest unit of computing, as we said. It's kind of been frozen out by cloud computing, by cloud native, and a whole bunch of other stuff that's come in, since then. Things like DevOps, things like an API architecture, things like serverless, things like event-driven architectures. So, Leo, is that kind of your definition of virtualization? What when people say virtualization, what do you think?
It is indeed. Yeah, I I have fond memories from late 90s, early 2000s, when I've seen one of the first releases of VMware, and on a absolutely atrocious, crappy hardware, we tried to run a virtualized operating system.
Yeah.
It more worked than it more didn't work than it did, but that was where it all started. And then the second phase really was that P2V consolidation, physical to virtual, which saved us probably a couple of times in some of the big projects. That was a big help, but that's where it stopped mainly for me. Like, when the orchestration of containers and the containerization jumped in, I think the virtualization in a way lost its plot to a certain degree, and it stayed there as an option still for doing more and more consolidations, moving workloads from one place to another that couldn't be containerized for whatever reason, although I can't see any reasonable reason not to do so, except for lack of time or resources or funding or whatever else. But from the technology standpoint, probably shouldn't be that much of a problem. So yeah, virtualization. When we talk virtualization for this specific talk, I do understand it as a unit of computing on the virtualized operating system level, and without willing to jump into the conclusion yet, is it dead, is it not dead, I think this one will be a little bit complicated in a way that there is a straight answer, but there's different aspects to it that are still relevant in nowadays data centers. Like, people would probably still, run KVM, Proxmox, and fire up virtualization, virtual operating systems, virtual partitions, virtual servers, basically. Having said that, what I see in our business, we grew in physical servers tremendously this year, 2024, but the demand for virtual partitions, VPSs, is close to zero. Literally, people would grab a server to first thing install Docker there, or maybe micro KAs, and just do their thing there with the Dockerized things. But are there many people willing to run a virtualized Linux box or a BSD or Windows if you need? I've seen a few use cases when people tried to run virtualized Mac OS systems, but that would be more like having a physical one with the remote access to it. That was quite a hot topic, but other than that,
I guess you'd probably end up having to maybe jailbreak those or something first in order
yeah.
And probably Apple would not be very happy with you.
Well, Apple is not happy with anything, but when it comes to creative use of their systems,
yeah, exactly. Okay, so yes, I think, with the advent of things like containers and orchestration, that's really kind of been the next unit of computing. And obviously, we're not going to, we're not saying kind of virtualization's, sort of dead over the weekend. Kind of go home on a Friday and you've got virtual machines, come back on a Monday and you've got containers and orchestration running Docker and Kubernetes and everything. It's going to be a gradual process, but certainly, dead in terms of not being the latest, unit of computing anymore. There is other options. There is very viable options where you can run your production environments. And actually, when you go to public cloud and kind of do cloud native, the preference is to use containers and orchestration and not to use virtual machines. Again, you can still do it, but it's not really kind of the thing to do.
What would be the reason to do that? Like with all the overhead? Why would you need to have, if you run 100 applications, do you want to have 100 times overhead of the whole operating system when you don't need to have? No. Exactly. So my take on it is more like, okay, if you have it, start planning to move away from it.
Yeah.
For the upcoming technology life cycle of whatever you have, 3 to 5 years.
Yeah.
And if you don't have it and you are about to build a greenfield environment, then, just don't look into that anymore because it's a thing of the past.
Yes. Yeah, I mean, absolutely. In terms of, how you, and this is, I think this also comes into part of your journey into cloud, going into cloud. And I have a, if you actually want to know a little bit more about that, dear audience, do check out my talk from with Trace Bannon, I think that I did in early 2024. So have a look at that. Because in that we actually talk a lot more about sort of the journey to cloud. And what we're trying to really do there is we're saying that, you know, as enterprises kind of move into cloud, they're going to hit a barrier at some point in terms of how much they can migrate, not necessarily just kind of migrate stuff into the cloud, which they have done, and we call that lift and shift. That's kind of the first stage. But really, in terms of how you develop new projects going forward, you can't keep migrating stuff into the cloud while you're still developing things in the old way. So you have to adopt, you know, more agile, modern ways of developing things like DevOps and platform engineering and agile sort of methodologies and so on. So you're right in terms of, you know, if you have the virtual machines, I'd say get rid of them as soon as you can, as soon as it's kind of possible, you know, and humane in terms of how you do it in your business in a humane way. But also you have to look at how you develop, you know, new projects, how you provision new projects, especially in the cloud. As you quite rightly said, you can't just keep on doing the same thing as we were doing before, because that gets you into a vicious cycle. No sooner have you got rid of some stuff and migrated into the cloud, you've got more stuff that you need to migrate into the cloud. So it doesn't make sense really to, you know, to do that. You do have to kind of move on to the next unit of computing at some point. And that does require that sort of, you know, agile DevOps sort of approach.
Absolutely. And it also reminds me of, yeah, like you probably, if you are a waterfall organization, if there are still some of these, it's probably hard to align beyond that. Here's an operating system. Here I will run part of the application here. There is a database server. I will run it on another VM, blah, blah, blah. That's probably hard to escape from that mentality. But as you develop more into kind of, as you said, DevOps platform engineering type of agile approach, these things probably come fairly natural and is a natural progression. Now, for that transition period of time from an organization standpoint, you will probably have these two worlds somewhat siloed. The one part of the organization, the older one, the legacy one, keeping your VM estate running and looking after things and all that, and your newer type of more agile organization starting basically developing applications, not necessarily from scratch, but maybe containerizing them, moving them into containers, and then migrating them of the old into new, or hopefully usually using the DevOps/platform engineering tools already, so that you are set for a higher level of granularity and automation going forward in what you can do with your applications and with your estate in general infrastructure.
Yeah, indeed. Yeah, I think it was Gartner talked about bimodal model a very long time ago. You know, kind of your sort of old approach of sort of your data center stuff, and then kind of your cloud, you know, approach, and that obviously that cloud approach being more cloud native. So I think if you're kind of definitely going to be cloud native, that is really what we mean by that. We have to look at those, the next unit of computing around sort of containers and orchestration, at least, if not actually WebAssembly, which is the next one. Although, as we'll maybe talk a little bit more about that later on, it's it's still kind of at a premature stage at the moment. So and I think, I mean, maybe before the 2000s, as I said, we had things like IBM, and you and I obviously worked for IBM. We had things like logical partitions, or LPARs. So that was kind of the approach that mid-range systems and mainframe systems used for virtualizing or sort of slicing their the hardware. And then they actually had the WPARs as well, which was a further stage, workload partitions, which was, I think, probably much closer to kind of, where things like containers are, right?
Yeah.
That's that kind of same concept, really. So LPARs
I mean,
and WPARs.
It's nothing new in the end of the day if you look at it from that perspective. What used to be available in those large Unix systems, AS400s
Yes.
and mainframes, just came over to the open world based on the x86 type of technology, right?
Yeah.
It did
Yeah.
just catch
Yeah.
up at some point and evolved, luckily,
Yeah.
as well. It's not just a carbon copy, but evolution of things, and that's where we are probably now going to see the shift away from the pure virtualization as we know
Yeah.
it, because that unit of computing, I'm looking at it like how much overhead it creates. And it does really. Like, why would you run the entire operating system for a small tiny app, or for an API gateway, or for basically an API type of application that just takes the data from here and there and you just need to process it somehow? It's
Yes.
different sort of requirements on that infrastructure underneath to make it run and to make it efficient.
Yes, and I mean, yeah, I mean, like I said, it's kind of last couple of decades, it's sort of served a purpose. And we had what did VMware start with? I think they started with GSX, wasn't it, and ESX. There were kind of
Yeah.
two versions, I think, of their solutions. Yeah. So I mean, the more recent one, I think that's probably needs a little bit more attention is around sort of AI workloads with GPUs. So GPUs are not virtualized sort of in the mainstream. So if your container or even your virtual machine needs to, execute some AI workload that it's doing, whether it's in a sort of foundational model training or something like that, it will actually hog the whole GPU. So GPUs themselves have not been virtualized, although there is technology. I think there's a company called Run AI that allows you to actually virtualize your GPUs, and guess what? NVIDIA's actually acquired them. So not surprising at all.
Yeah,
but I mean, that's that's something else to look at as well in terms of virtualizing GPUs going forward. Okay, so yeah, let's look at some of the kind of the identity of sort of virtualization platforms. So we mentioned vSphere from VMware. That's really kind of been the the main sort of leader, I guess, in this sort of virtualization world. Ever since its announcement, I think it was in the late 90s, and then really sort of took off, started taking off a couple of years later in the early 2000s. VMware vSphere, ESX, and then ESXi. I think that's the embedded version, the integrated version that was provided. So actually, that went into service, physical service. You could actually run it on a USB stick or an SD card or something. I think even IBM, in IBM, we had that built into some of our x86 servers. So vSphere's kind of been the main one, but there's obviously alternatives that have come out since. So things like OpenStack. You and I have obviously covered OpenStack, and it's dead as well. So what's the point of mentioning it, really? It's just for posterity. That's why. But then also around the open source space, there's been things like KVM and Zen. What's your view on those? Have you had any experience with those?
I had KVM installed on some of the servers. I came across it. A couple of projects where there was Zen. But you know what? To me, it was just, a tool that basically, all it did was virtualization. On whether it was a native Microsoft one or an open source one, I couldn't find that much of a difference, to be honest. I mean, recently, in the recent years, I was looking at Proxmox to maybe virtualize some of our biggest servers into more sizable chunks, and then it never happened because it was running Linux anyway. So either we just run Linux containers or LXCs, or we just went straight for the Docker anyway. And so I have beyond, to be honest, beyond VMware and maybe the KVM, and as I mentioned, Proxmox, fairly limited in-depth experience of those, because to me they were like, okay, one is red, one is green, one is blue, but in the end of the day they do more or less the same thing, and they do it fairly well. So why bother if it's that or this, except for do I want to pay the ransom to VMware in terms of licenses?
Yeah. Well, yeah. So I mean, obviously the cost is, the licensing has been really what's driven VMware for the last sort of 2 decades. Unfortunately, it's driven them into the ground because they've, not really modernized or haven't had really a cohesive strategy around modernization. So they acquired Heptia, as we, I think, had a conversation on last time around, and they integrated their Kubernetes distribution into vSphere as Tanzu. So that was the solution they had. But I think by then it was kind of, quite late in the game. Everybody was kind of, moving on to Kubernetes and other distributions of Kubernetes, including things like Red Hat, OpenShift, and the public cloud ones, the XKS solutions from the public cloud providers as well. So yeah, so I mean, KVM and Zen, it's been, I think, if you know what you're doing, and if you're kind of part of that sort of Red Hat and the Red Hat enterprise sort of virtualization rev, I think it's called. If you're kind of part of that sort of scene, then I guess you could use KVM and Zen. It also kind of made a bit of an appearance on OpenStack, because it was the virtualization platform or virtualization solution that you could use on the OpenStack platform, right? So again, people kind of looking at OpenStack thought, I can run my VMs on OpenStack. No, you actually still need yet another layer before you can actually run any
layer over layer over layer. Yeah, of course.
Yeah, exactly. So that kind of,
that's why it's called OpenStack.
Yeah, exactly. Yeah. Well, yeah, that's why it's called the stack. Yeah. So the point is that you had, with OpenStack, you had multiple layers to deal with, and then with KVM and Zen, it was kind of confined to that sort of open source Linux, sort of space. I don't even know these. I don't know if you might have experience with this, whether KVM and Zen are actually there as modules that you can install on Linux. Are they still provided on like general purpose, like Ubuntu and stuff like that?
To be honest, I didn't check in the past couple of. It's
nobody's bothered looking. It's the last 20 years.
I mean, what's the purpose of these? I mean, don't get me wrong. It's probably still there, even as part of the standard packaging managers. But what would be the last time I would be looking into this and wanting to give it a go? Well. Probably a decade ago.
Yeah.
No, I mean, look, here's a thought that was just forming on my mind as we were talking, and that is maybe the operating system virtualization based on whichever tool was fit for the purpose and you had preferences with, had its justification in the world where you had a really large machine, a big unit of computing that you need somehow to splice to sizable chunks to either in your organization or as a cloud organization or whatever would be the purpose. But as we move to also smaller units of computing on the server level as well, and as it made more sense to just say, okay, we have this cluster maybe for dev test prod 1, prod 2, prod xyz to run workloads on. Suddenly there was probably no need to virtualize on the operating system level, because even the hardware got a sizable, still high performant, but not this, mainframe-like or large Unix systems like the ones that we knew from IBM or Fujitsu or whomever else. Those days are probably gone as well, and hence the need for the virtualization of the operating system to make that system, that large scale system, more usable is literally gone.
Yeah. I mean, I think we're just kind of trying to really sort of understand that a little bit more and dig a little bit deeper into it. But like I said, I think vSphere and kind of with the more recent sort of Broadcom acquisitions not really, I think, helped at all. That's been
that's an understatement.
That's being diplomatic. Hyper-V was always Microsoft's sort of counter to vSphere. So it was very much within its ranks and within its sort of walled garden and ecosystem of corporate customers and so on. Yes, and I think it was a very viable solution. I had lots of customers using Hyper-V. And although it wasn't taken seriously, I think at the beginning, it certainly was in later iterations and really, running production systems for customers. And I guess that probably made Microsoft, sit up and pay attention as well. They probably threw it out there and say, you can kind of do some virtualization on Windows Server if you like. But then actually customers thought, oh, actually, yeah, we can do that. And we can avoid maybe the extra vSphere license. And then Microsoft kind of took a big sort of gulp, and thought, actually, they're starting to use it. Oh my God, we better develop this and make it work properly. So then they actually developed it and it became a lot more viable. And I had, hundreds, if not thousands of, virtual machines running on Hyper-V in certain customers that I dealt with, mostly in the kind of financial sector. Yeah. And we said OpenStack's kind of a beast of its own, really difficult. We've covered this a lot. You need extra layers on top to really run any virtual machine. So you can just kind of install OpenStack and throw your VMs on top of that. You still needed KVM or Xen or whatever to run on top of that. Proxmox, I think that's kind of a more recent contender. I've not really seen a lot about them. I mean, I could be wrong, but I don't really know a great deal about them, to be honest. And I don't know where they're sort of coming from. Are they KVM Xen based? I'm not really sure. I don't know what technology they're really based on.
My memory serves me correct. It's KVM.
KVM probably, yeah. Okay, yeah. So again, it's kind of a variation on the same theme. And then you've got obviously things like hyperconverged infrastructure with the likes of Nutanix and some of the other sort of players in that space. But again, we won't go into that too much.
Are we doing the "is Nutanix dead" type
of? We might do is hyperconverged infrastructure dead? Yeah. But again, don't forget Acropolis, which is their platform, is really KVM. It's KVM based. So again, variation on the same theme again. As far as that's concerned. So all of that's kind of Sorry, yeah, go on.
Yeah, what is that? Is if we look at that world where you would have a rack stacked with server storage and networking and literally stashed the OpenStack-like virtualization of everything on it, including that base layer of operating system, that is definitely gone. And thank God for that, because that was incredible amount of complexity that was to be managed.
Indeed. Okay, so let's move on to looking at really kind of the details of where sort of virtualization comes from, and what are some of the issues that we see in comparison with maybe containers and things like that. So the first, I guess, of those is sort of the heritage. It comes from the data center. It kind of comes from that world, from those days where people were, there was no kind of cloud computing in those days, in the sort of sense that we have it at the moment. So we kind of focused a lot more, on a sort of it's a generational sort of thing. And it's kind of really now 2 generations out, if you count containers as well as WebAssembly, as kind of, as we said, being the sort of the next unit of computing. So already not a good start, and that was already, you know, kind of from a previous generation and from a environment that, you know, most enterprises are moving away from, you know, generally speaking, kind of that sort of data center type of approach. Next thing, I guess, is, and I think we touched on this a little bit, footprint. So in terms of resources, so a virtual machine requires, you know, it's a full emulation of a physical server. It, you know, connects into the BIOS and things like that. So it really requires a whole kind of full virtualization in order to fool really the application that is running on a physical machine, because the application is not being changed at all. Application is getting an easy ride into virtualization. In most cases, probably 99% plus of cases, there's no need to make any changes to the application. But the one that actually is affected, obviously, by, you know, that emulation is the operating system. And the operating system kind of, you know, needs to have some kind of capability and you know, and in order to, you know, run it in that environment. But the you know, the idea that you're having to you know, emulate an entire physical server, it automatically adds, you know, a bunch of resources that, you know, will be required for every physical virtual, or every rather virtual machine that you need to run, right? So every virtual machine needs the same resources to emulate, you know, that physical server, to, you know, talk to the physical hardware via the hypervisor, of course, and also to, you know, fool the operating system and fool the application, you know, to run as if they were running on the physical server. So resources, size of virtual machines really kind of, you know, grows quite large. You know, I saw sizes in some virtual machines being, you know, gigabytes worth of, you know, storage, which again begins affecting your, you know, your physical storage or virtual storage, whatever you've got in terms of your disk. Again, whether it's local or a SAN or whatever it is that you're pointing to, or even actually in, you know, in cloud environments, it'll still be a huge amount of, you know, storage that you require. In contrast with a container, which is much more, you know, as we said, self-contained, hence the, you know, hence the term containers, yeah. Since everything is in the container, it doesn't need a full fat operating system, and indeed it doesn't actually need a dedicated operating system. And we'll come back to the cost thing on that in a minute. But it doesn't need a, you know, a fully dedicated operating system. That's, I think, one of the main differences, and probably one of the, you know, differences that's not really highlighted a lot in terms of that you know, you don't actually need that full operating system to, you know, to run your application and to run your container. Hey, if you are enjoying the content, please don't forget to subscribe to the channel. That would really help me out. Thank you.
I guess where the sweet spot really is, or where the main advantage of it is, like, you know, why to waste 100 times a gazillion of resources to emulate the whole machine if you just need a tiny bit,
exactly,
and share the underlying hardware across basically hundreds of thousands of containers.
Yeah. So yeah, and we'll try and make some visual available. So we'll try and maybe make that available on the screen now. If not, it'll be in the it'll be a link or two in the description of the video, so you can actually kind of appreciate the differences a little bit more visually. But yeah, essentially, you know, physical server, you know, hypervisor, virtual machine, operating system, and then application as far as virtual machine is concerned. And then on the container side is physical server, if that's what you're kind of going to do. You could, you know, do a comparison. It's the runtime.
Unless you want to run Docker or anything similar in a virtual machine in an open stack environment, which we said we don't want to do.
We don't want to do that, no. Yes, but just for comparison's sake, to kind of keep it as even as possible, you know, physical server, the singular operating system that you need and that can be a small footprint operating system to run your orchestration platform, which will most likely be Kubernetes, and then you just run your runtime for the containers, and then your containers, and that's it, and your applications within that container.
It's interesting how, when you look at it, how we came back from the full circle. First, virtualize the hardware, virtualize the whole operating system. Now ditch the operating system virtualization and go back to containerization and just use whatever required from a physical operating system on a physical machine, and leave the virtualization completely out of question, right?
Yeah, exactly. Yeah. So I think that's like I said, I think that's one of the undersold features of containerization, that the amount of resources that you're saving on storage, performance, everything is, and even
moving from one machine to another. If you have a clustered environment, although probably not very many people would use swarm clusters. It would be more Kubernetes ones, but even though, you could still migrate quite easily from one cluster to another, all the workloads between the worker nodes. So, if you really need to replace a full node, you can easily do that, even though it's not a fully virtualized operating system, right?
Yeah. So I think the factor there of going from, and just kind of, pressing the pause button on the advantage and disadvantage for a minute, but the factor of going from virtual machines to containers, allowed us to really look at containers as, finally being able to treat those resources as cattle rather than pets. So virtual machines was the pets. So we looked after them, nurtured them, fed them, and watered them, and everything else that they need in terms of their resources and maintenance and so on. Whereas containers, if they die, well, we just spawn another one. We just start another container with the same service, with the same application. We don't really care necessarily about the container that's died or hung or crashed or whatever.
I love that analogy.
Yeah. So we kind of went from from pets to cattle, really, and this was the first time, I think, when we were able to actually do that with the advent of containers versus how virtual machines run, because virtual machines are a copy of our physical servers, and we used to we went from the host servers the host server being the important thing, to what is this service the applications providing in the cloud being the most important thing. And this is HashiCorp does a really good, I think, job of explaining the difference of how we kind of went from from that sort of approach with virtual machines to containers in the cloud, or at least data center in general versus public cloud kind of approach to how we do those things. I'll again try and drop something. I think they call it a cloud operating model. It's not exactly a cloud operating model, but it's HashiCorp's cloud version of a cloud operating model. Anyway, so that was kind of the cattle versus the pets. I think that was or the pets versus cattle was kind of the thing there. So definitely footprint. In terms of resources, you save a ton of resources. Even if you actually just stuff your old monolithic application from the data center in a container and run it in a container, you still save a lot of resources there. It's not perfect. It's not the greatest solution. But I've spoken to a lot of system integrators, and they've all pointed to that stage in the migration, in the journey to cloud, and said, "Oh yeah, that's what we do for our customers." And I've said, "Really, you guys kind of put the old apps into containers?" "Oh yeah, we do that all the time." So it's actually a viable solution. It's not perfect, but it's not great, but it's still something that you can actually do. So that's certainly part of I think the difference is there, that footprint and the amount of resources. You use a lot more in VMs versus containers. Ecosystem is another place. So kind of having a sort of a proprietary approach one vendor or two vendors, so having kind of, VMware with vSphere or, OpenStack or whatever, or, KVM on the Linux side, versus a more open sourced sort of approach. And you can have, lots of different versions. Everybody, runs Kubernetes, regardless of which distribution you get. It's still Kubernetes at the end of the day, and you're still doing kubectl stuff or kubecli stuff or whatever, CTL stuff or whatever. Also, the same thing with with your containers. So it's Docker all the way. There's no other containerization. Yeah, you could maybe play with Linux containers or whatever, but really Docker containers is kind of the generalized standard there. And again, you can get that from anybody. You can get that from Red Hat. You can get that from the the hyperscalers, the public cloud providers, or whatever. And everybody's kind of conforming to that open standard, if you like, versus a proprietary solution from VMware or somebody else. So again, ecosystem, I can think makes a lot of sense there. I mean, I could roll off a whole bunch of other stuff here. There's things like automation and provisioning. So the same thing as kind of the ecosystem is you have very little of that, and if it's there, it's very proprietary to that platform. So you've got vRealize, you've got vCenter and stuff like that. Very focused on VMware's vSphere and nothing else. As a sort of a
which leads us to the question of, is VMware dead, right?
Well, yeah. So that might be another discussion. But yeah, I mean, certainly, I think in that sort of space, and I think I've actually covered that. We have covered that in a Cloud State of Play talk in the past about VMware themselves, certainly within the sort of the with the advent of the Broadcom acquisition. But that sort of automation, provisioning, again, very focused on the ecosystem. Maintenance and patching, yet another area. So how do you maintain your hypervisor, your virtual machines, and everything around that sort of ecosystem? Again, all very proprietary to each ecosystem. So vSphere has their own, or VMware's vSphere has its own with vCenter and things like that. You can do your maintenance and patching, using those tools. Even if you're actually using latest automation tools to do some of that work, so maybe using things like Terraform, it still has to have an integration point into that ecosystem. You still need some kind of a connector of some kind, an interface that will allow it to address that environment, whether it's going through vCenter or whatever.
And still a lot of people involved as well.
Yes.
Because, I can't go into details, but one of my enterprise clients, whenever they run patching, it's tons of people on top of that involved throughout the weekend just to, run through the process of patching end to end. And of course, there's certain part you can automate always, and someone needs to be there to push the button.
Yeah.
But once you push that button, you still need to verify and, did everything go wrong? Well, most likely that you can automate as well, but then cover all the edge cases where things didn't go that well and all that, which is, I guess, the price we pay again for the complexity and for the overhead that it takes virtualizing on that unit of computing on the whole server level or operating system level rather than on a smaller units such as containerization.
Yes, and I mean, and like I said, with containers we deal with infrastructure as code. That's how we don't normally do things. We don't do it through ClickOps. Right? We're not sitting there clicking in the AWS interface, creating our environment, creating our Kubernetes cluster, bringing in our container images, blah blah blah. We don't do it like that, right? We use infrastructure as code. You can, like I said, retrospectively still do that if that's what you really want to do in your vSphere environment. But I mean, how many people are actually doing that, right? How many people actually automated that? They're most likely using the tools from VMware versus an open source tool like in a Terraform or Ansible or something like that. So that whole sort of maintenance and patching, you're quite right. There's lots of, it used to be, floppy disk and CD swapping over the weekend on your, on your data center racks. Now it's probably USB sticks or maybe some kind of remote capability, but it's still those proprietary tools that are within that, ecosystem. The other one I think that I picked up on was architecture. So architecturally, virtual machines are kind of the old design. When you look at kind of how we, did things again in the data center, it's not the cloud, it's not the sort of the cloud native approach. We look at, it's typically a sort of a three-stage or a three-tier application, right? In a front end, business logic, in a back end, and whatever, or database or something, versus the 12-factor sort of approach that you do, with cloud native. So again, architecturally, some of the old architectures can't really sort of operate in the cloud. We can't really do cloud native with those things. So we have to change the way that we, again, design things architecturally. And again, containers and WASM and all that kind of stuff lends itself a lot more to that cloud native approach versus, virtual machines, and indeed hypervisors could actually do. Does that make sense?
Makes sense.
Do you agree with that?
Yep.
Okay, right. Okay.
Nothing else to add really on this.
Yeah. Well, I mean, I think it's a fairly straightforward, point, but that's certainly one of the contrasts there.
There's one element that just came to my mind, and when we speak about virtualization, it's and I don't know why it didn't come to me any earlier, and that is some of the financial sector clients and also other sector clients would force their end users to go and log in via Citrix or similar to a virtualized desktop.
Yeah.
And I don't think that will go away anytime soon, or at least I'm not seeing much of a development in there. If you are regulated, you probably don't want to allow bring your own or connect your own device into our resources and infrastructure and stuff like that. You want that literally physical distance between you and the computer you're accessing somewhere behind multiple factor authentications and stuff like that. So I think that is probably, and that's probably where the Hyper-V still will be alive for a certain amount of time, because that tends to be Windows workstations virtualized based on Microsoft technology, right? So, so that one I think will still be around. I don't necessarily am a fan of that. It's something fairly uncomfortable, slow, and atrocious to work with, especially if there are other corporate policies on how fast that thing time out when you don't touch it, disconnects and shuts down even, which if you have a terminal session running in that environment and you forget to run them under tmux or something like that, so that they don't necessarily are dead as soon as that ping dies on you from the desktop perspective. That's but that thing probably will not go away anytime soon, sadly.
Yeah, and I mean, I'm, to be honest with you, I'm okay with that. I think that's VDI, and that kind of space is actually a good space for virtualization, or at least until, I don't know if anybody's done it, maybe putting that kind of image into a container. I don't know if anybody's done that. I'm not really sure if there's any solutions for that, but certainly for the moment, I see that as actually a really good space to be. And in fact, it would have had a lot of customers done that, a lot of enterprise done that. The whole CrowdStrike outage would have probably been minimized, because they could have just reset the image and gone back to the previous image, and they'd been, within an hour or something, they'd been up and running again. If a lot of them were using VDI, but clearly they weren't, and that's why they were kind of especially the older non-agile sort of environments, and that's probably why they were affected so much by CrowdStrike. And again, we did cover CrowdStrike in a Cloud State of Play, I think it was the August episode of 2024. So do check that out. And I think there's probably an unfiltered episode of that as well. I'm going to go into a lot more about the CrowdStrike outage.
My conceptually or architecturally, my main reservation, so to say, against the VDI is that you typically use a machine already to connect to yet another machine.
Yeah.
And that to me somehow doesn't make sense. And all I do on that remote machine is probably open a terminal session via SSH somewhere.
Yeah. Yeah. Yeah.
Why not a properly secured VPN connection and run the terminal from your end? And I get all the arguments why not and blah blah blah, but conceptually just still, I know why it's there, but it's somehow, if you look at overhead and resource optimization and all that, it's still not optimal.
Yeah, I mean, I think just generally, running virtualization for VDI, whether Citrix or otherwise, to control those types of workloads, the end user kind of computing workloads, I think that's fine. And I think more than happy for virtual machines to be kind of kings in that in that particular space.
If it stays there, but go away from the server estate. We don't need you there.
Go away from the server workloads side of things and the cloud native side. Yeah, thank you very much. Okay, so that's kind of set here. Then the next thing I think would be things like agility and innovation. So infrastructure as code we mentioned. That's kind of how we can stand up things very quickly in the cloud. And by the way, one point I forgot to mention, and probably agility is a good point to mention that, talk about it, is the cold start time of virtual machines versus containers. And again, this in certain environments, again, like financial and trading and so on, is absolutely essential to be able to kind of recover from something or start something very quickly, do whatever you need to do in terms of financial modeling or whatever it is that you're doing, and then to shut that environment down. So again, milliseconds is crucial in those environments.
Also spawning more containers compared to more virtual machines, right?
Exactly, and being able to cope with a surge in demand, whether it's kind of your Christmas time, lots of people are on your website ordering stuff, and how do you deal with that? So containers again kind of can deal with that sort of ability a lot more. And actually, WebAssembly takes that even a step further, because that obviously can step up and be spawned a lot more quickly as well. So there's a lot of these kind of things that really where containers are infinitely better than virtual machines. The next one I think along is costs. So we talked about kind of every virtual machine needs a full fat operating system, but every container does not need a full fat operating system. And because of the pets and cattle's difference between the two that we mentioned earlier, again, you can save on the operating system licensing costs, at least when it comes to containerized environments versus virtual machines. And then the other one that you touched on briefly was resources. So the amount of resources and the type of resources, which leads you into kind of your skill set as well going forward. Do you still want to kind of be doing vSphere and or OpenStack, God forbid, or something like that? Or do you want to kind of be cloud native, Kubernetes, Docker and DevOps and all that kind of other, fantastic
Choose
stuff
one path and stick to it somehow.
Yeah, exactly. So I think all of those things are kind of the angle of attack that I think more modern environments like containers and indeed even WebAssembly has over the old sort of virtual machines and hypervisors. I mean, we've essentially with containers kind of done away with the hypervisor. You just need an orchestrator, something that just runs your virtual machines, your containers, but doesn't really care kind of what they're doing. It deals with the I/O, the ingress and egress of your network, but that's about it really. And obviously, can spawn them and kill them and whatever if necessary, depending on the rules that you've set up. So heritage, footprint, ecosystem, automation, provisioning, management orchestration, maintenance and patching, architecture, agility and innovation, costs, and skills and resources. Those are all the areas I think where we see a lot more advantages with containerization than we see with virtual machines. Is that kind of a full picture for you, Leo? What's your sort of...
It is, yeah. And thanks also for mentioning the skill set and all that, because it's probably those who didn't necessarily manage to upskill into containers, its management, provisioning, somehow taking care of it all and treating it as an infrastructure, as a code, and all that DevOps around that. If you stuck in your 2000s, 2010s, where it was enough just to get yet another useless certification from VMware that you could do this and that in the vCloud directory, and you were an expert level of this and that. That's a thing of the past. And if there are still those kind of people with that skill set in your organization or a particular organization, probably it's time to retrain and start moving them away from that specific proprietary technology to something more, as we say, cloud native.
Yeah, indeed. Yeah, I think we have a name for them. They're called server huggers.
I haven't heard that one.
Huggadel server. Huggadel server huggers. Yeah.
I mean, it goes as with anything in the technology industry, as in my days, like 20-25 years ago, your days too, it probably was enough to reinvent yourself every 5 years.
Absolutely.
Then it was probably every 2 or 3 years. Now it's probably every couple of months.
Yeah.
I mean, look where we were 2017, 2018, 2020. It's 2024, and it feels like the way the things evolved between, say, 1990 to 2000 is probably what's been going on in the past couple of years, right?
Yeah. And I mean, I spent like 15, 16 years at IBM, and I held 3 roles. And there was a reason why I did that. Is because I wanted to do something else. I wanted to move on to do whatever the kind of the next thing was. Okay, so futures. Let's talk about futures a little bit and kind of just round things off. So with the Broadcom acquisition of VMware, I think
VMware is dead. So
VMware is dead. Basically, the nails in the coffin are being hammered in as we speak.
Yeah,
right
the
now.
jury is out, and it's just a matter of time.
Yeah, just a matter of time, indeed. Just delaying the inevitable. So again, as I said, if you guys want to check out anything on the whole Broadcom acquisition of VMware, do check out some of the previous episodes of Class State of Play. We've covered the whole thing extensively, actually, and kept up with that. And we discussed some of the antics that Broadcom pulled in early 2024, actually late 2023, early 2024, on the whole sort of VMware customer base, channel, partners, and things like that. So lots of that has been covered already, but I'll maybe try and drop a link or two in the description of the video if you want to kind of go back and have a look at that. So again, as we said earlier on, that there's not been really any innovation in the whole sort of, virtualization, the VM and the hypervisor world. A VM is a VM. You're never going to be able to cut corners with it or reduce its size in some way or some kind of innovation. A hypervisor is a hypervisor, regardless of which one you look at. It works on the same principle. So again, you're not having to, there's not really kind of any innovation there. So that's not moved forward, nothing new there. And, like I said, VMware was kind of really selling vSphere. And I'm not necessarily picking on just VMware, but it is the most, used and, predominant sort of, hypervisor virtualization environment, right?
I mean, They've had
Everybody
the
has
first
it.
mover. They had the first mover advantage, right?
Yeah, and they had the
From
first
the
mover
outset.
advantage, at least in the x86 world, and indeed
Yeah.
that was the more pervasive kind of space. So again, vSphere, ESXi, that whole kind of thing has really done nothing. It's still the same, over the last sort of two and a half sort of decades or whatever it's 25 years or so. We mentioned Tanzu. This was really, I think, VMware's sort of, a knee-jerk reaction to stopping the hemorrhaging of their customers to cloud and to containers. It was kind of, hey, look, you can do containers
We've
with
got
vSphere.
it too. Yeah.
We've got it too. Yeah. But the point was not that. The point was to move away from that environment altogether, so you can be free of those shackles of that whole sort of, vSphere environment. And, VMware even tried putting vSphere on the other side of the fence. They threw it into the public cloud. They probably won't say it, and the public cloud providers won't say it, but I'll say it. They probably paid them a ton of money to take on VMware Cloud or VMC. And I don't know if anything is happening. Do we have any figures on how many people are using that? I've not seen anything public from VMware themselves or the public cloud providers or hyperscalers or anybody. Not even IDC, not even Gartner, not even the
complete silence. Yeah,
the research houses, exactly. And anyway, the likes of AWS pulled out in early 2024. Anyway, they said, as soon as Broadcom kind of came in and abolished the VMware channel and all the partnerships, AWS was the first one to pull out. So they're no longer actually, selling VMC directly. And I'm sure they were very cut up about it. Their press release sounded like they were really cut up about it. So yeah, I'm sure they were very devastated by that news. So anyway, we've covered this again before in the past, Class Data Play and various other places. Do check that out. But what can we do to look forward to the future? What's kind of, we can talk about migration to cloud. We can talk about this, we touched on the journey of the stages to cloud, of how you kind of go from, lift and shift all the way to kind of DevOps and serverless and so on. But what else can you suggest, Leo?
Look, this leads me to one other thing that you mentioned earlier on, that some of the application providers just skip the virtualization and build the containerized version of their legacy application instead. And I think I've heard about it. I haven't seen it in action somewhere, but I think that's a clever thing to do for if you are in doubt right now, you want to get rid of your virtualized operating system / machines, and you run legacy applications, maybe looking into how to virtualize your legacy application in the form of containerization is a way forward to free you up from the legacy of VMs. That would be sort of the bridge from where we are right now into the future.
Yeah.
And, my ideal future is, especially in the server world or infrastructure world, get rid of virtualized machines, virtual machines and operating systems altogether.
Yeah, and as soon as possible, indeed.
And as soon as possible, yeah. Yesterday was too late.
Too late, yeah. So that, I think, as we said, migration to cloud, despite all the, I think the FUD that you hear in the press about cloud repatriation and so on, it's still, I think, the future, especially with, I think, generative AI workloads. If you're going to be into that, I think it's ludicrous to think about, unless you're, in a particular type of market sector, and you have regulations or whatever, I think it's ludicrous to think about running that locally anywhere. I think most people will not do that anyway. They'll probably realize soon enough that that's not the case. So that's not the right way to do it.
It's probably a good topic for another talk, but
yeah, not a dead tech talk, but
well,
something else talk. Yeah,
where open source got it wrong in the AI space is
let's not go there. That's that's a whole topic. Yeah? There's a whole storm brewing in that space. Yeah, with the OSI declaration and so on. Yes, there's a whole storm brewing there, definitely. So yeah, maybe that's something to explore, definitely. But point being is that migration to cloud. Look at the stages of the journey. There's multiple stages. Like I said, look at the video that I did with the talk I did with Trace Bannon. So as we go through the 4 stages, what I call the 4 stages of migration, and certainly look at cloud native. So kind of the adoption of DevOps and platform engineering and kind of that whole sort of cloud native approach. That's really where you need to be sort of focusing. That's where you take full advantage of cloud computing. Okay, any other thoughts, Leo? I'll be exhausted.
I ran out of thoughts. I think we exhausted it all.
We've exhausted it. Okay, all right.
As always.
As always, yes. I think we've spent enough time on this as well. Okay, so Leo, thank you very much for joining me. I really appreciate your input and comments.
Thank you for having me again.
Yeah, no, not at all. Yeah, absolute pleasure.
Next time, hopefully, not a dead talk.
Yeah, hopefully next time we won't be a dead tech series talk with you. We'll move on to something more positive, I think, next time. Yeah, so thank you very much for your input and comments. Really appreciate it, as always. Do check out Leo. Like I said, I'll drop some links in the description of the video on Leo, what he gets up to, all the various links for his channels and stuff like that. Do check that out. Please subscribe to the channel to support me and Leo's channel if you get a chance to go and have a look at his stuff. It may be something trivial, but it's really important, and it really helps me out and kind of helps me to produce more of this type of content. So if you do appreciate that, please consider subscribing to the channel. Thank you all very much, and we will see you next time.